Hey everyone, so today we're going to begin our tutorial series. This is essentially going to be the first episode for the Box2D uh, integration or utilization, and all we're going to be doing today is just getting a basic Box2D renderer up, which will display the physical objects in your Box2D world, along with some simple camera motions. I might just throw an interpolation for the heck of it, but that's not going to be our main focus, so don't really focus on that as much when I throw that in there. But for the most part, by the end of this project tutorial, we will have a box moving around in a black void, and it will have some gravity applied to it, and it'll fall on a platform. And that's about it. You'll be able to jump, maybe move left and right, but all in all, it's just going to be very, very simple. So with this, what I have here is just a basic project that you get from the LibGDX project setup, project generator tool. These are the settings I used to create what you see in front of you, except I made a few modifications. I am under the I'm sorry. I'm under the assumption that you already know some Java for the most part. It's definitely necessary for these tutorials. If you don't, I really recommend just practicing a little bit before jumping into game development, as game development is very time consuming, math heavy, and depending on how good of a programmer you are, it's very important to do a lot of code hardening. Um, so as you see, I am only doing the desktop and Android sub-projects. I'm not going to do iOS because that's not necessary right now. We're not really looking at a mobile to begin with. I probably shouldn't have even done an Android one. And HTML, I'll probably cover some of that stuff, GWT stuff later. Um, so we have free type, tools, controls, Box2D, Box2D lights, Ashley, AI. I all just kind of grabbed them all just so I don't have to do it later, even though I know it is pretty easy with Gradle to add those. Um, but I will be trying to cover each and every one of these uh, for future tutorials. So if you're looking forward to implementing any of these to utilize their strengths, then be prepared because they will be coming eventually. So yeah, I just generated an idea project, which is what I'm using IntelliJ, and then I imported it, and um, here I am. I added a few things already. Essentially, what you get when you first use the project generator is a project that displays the bad logic image. I don't think it's their logo. It's just some placeholder image that appears on screen with a red background. So if you want, you can just see here and pause the video, have or start entering what I have. I definitely recommend typing alongside me if you can. It's good practice and it's good muscle memory to get used to some of these things. Um, and also to note, I have in my desktop launcher um, there's this config class. You're able to change the configuration settings for when your application is first run, such as the width and height of the window, and to kind of lock it to a certain frames per second to make sure it has a consistent frame rate. I do that just for testing purposes, but it is good to do that in general just so you can make sure your numbers are right, and also to make sure you're utilizing your delta times properly. You can change it to 30 and you'll get a slower kind of emulated frame lag, and then you can kind of work around that to make sure your project is working if effectively and your numbers are all right, and your calculations will be right. But anyway, that's not really the focus of this video. So let's say we just jump right in. Apologies in advance. I am still trying to get a format down, so there will be a few stutters here or there. You can just turn the volume off or something and just code alongside, or listen to my voice if you like. So with that disclaimer, we will jump right into making our camera. Camera is good to control the viewport of your game. This is essentially what the player will see. You can pan it, zoom it, flip it, do all sorts of things with it. It's really nice and really handy to use, and essentially every single project has some sort of camera or another. So for a 2D game, we're going to be using an orthographic camera, and we'll just call it camera. And we'll just import that real quick. Let's see, so camera equals new, orthographic camera, and we're going to want to set it false, width divided by 2, height divided by 2. If you do remember from me showing you a second ago, I have the height set to 720 and 480. I'm dividing those by 2 just so I can get a little bit of a zoomed in view, so we don't see like tiny little objects, hard to see. You can essentially change that if you want, but I just like to work with it that way. So also down in the resize method, if you don't have this method yet, you can add it. It is part of the abstract class of application adapter, so it will recognize the override. So we want to do the same thing we just did, set to ortho false, width divided by 2, height divided by 2, width, height, and what else? So dispose. Yeah, so that should be it for now. And what we have here, even before the camera, I'm sorry, I forgot to show you. I have it set to black RGB values, red, green, blue are all 0 when the alpha is 1, and then I clear the screen. That's kind of like a double buffer effect. So after we run it, the first build is, or the first time running the project is always kind of slow, so bear with me here. What we should get is a black screen. And let's see. There it is. That's it. So this is our game so far. Nothing fancy. It's pretty fun, right? So yeah, let's start moving into this render class. Let me explain a little bit about it. In other smaller game libraries, such as like I'm not sure if a lot of people have heard of Slick2D. That was a pretty big one a while back, developed by Coke and Code. He kind of roams around on the Java game forums, but I think he doesn't do too much game development anymore. Anyway, it essentially had two methods. There was an update method and a render method. Now the update method is supposed to hold all your game logic, where you do all your arithmetic and updating where players' position are, enemy position, game logic like collisions and stuff. And then the render method is where you print all that to the screen. And how games are developed, you do all your logic updates and then you render. So to follow that same pattern, with LibGDX, all they give you is a render method. So we're going to just kind of make our own update method, which will contain all our game logic code. And we're going to hand it off. Let's see if we can find it. No, whoops. Graphics.delta time. Okay, that is going to be our delta. Essentially, that is the amount of time it took between a frame refresh. And that's how you can compensate for lag, as I was discussing earlier with this number. So let's get into that. Void update float delta, and we'll kind of use that later in other projects, but I don't think it's absolutely necessary right now, just because Box2D takes care of a lot of things for us. So speaking of Box2D, let's get a few of our variables set up here so we can start working with them. world. We'll just make a Box2D world. This is essentially what you work with. It's where you put your physical body objects into, and it kind of does all the math and physics and impulse forces and velocity and all that stuff for you. You don't have to do any of the math. It's really nice. But if you do want to get into more complex motions, you will have to start to understand how impulses are applied to objects, and it gets a little tricky sometimes when you have a lot of fixtures on a body, and I'll kind of explain that stuff later. So we have a world. Let's say we also have a body, and we will just call that player. This is just an abstract idea, a body that we're putting into the world. The player is a body. It is an entity that we are going to create. And what we're going to do with it is just kind of make a box, just a simple box. And to do that, we should first get our world set up. So to get your Box2D world going, you're going to have to create the world equals new world, and then it's asking for a gravity vector. Vectors are essentially, as you would see on a Cartesian graph, it's just like an x and y value. So new vector 2, let's say 0, and we'll use real life gravity force, and we'll also say false because we don't want our world to sleep at all. So there we go. And then to view our world, like for the world to show us what it looks like, you have to use a Box2D renderer, and that essentially will draw out all the lines and shapes of your Box2D objects, and it'll give like basic information of what your world actually consists of, and what it contains and how it's structured. And your camera won't do that for you. Your camera is more the end game, or the end development, kind of like it shows you the actual game, not the kind of debug stuff behind in the background that most people don't see anyway. And I'll kind of show you what I mean by that when we get to implementing the debug renderer. So let's get that going also. Private Box2D debug renderer. We'll just call that B2DR. This is such a long name. And we're also going to do that right below it. So B2DR equals new Box2D debug renderer. And there we go. That's it for that so far. And let's see, where are we at? So we're going to want to dispose that, I believe. Let's see, dispose, yeah. Okay, so what dispose is, it's kind of good resource management. It's how you make your game stay efficient. If you start loading in a bunch of these batch renderers and debug renderers and stuff like that, and the world too itself is a pretty big resource to use sometimes if you have a lot of objects in it. It's always good to dispose it. That way it clears out the resources for your computer. It keeps the game clean. It allows it to have a good footprint. So with that, oh, I also forgot to add world.dispose, yeah. So always make sure if you can dispose something, throw it there. And when we get into further tutorials, I'll kind of discuss asset management, such as textures and music files and stuff like that. You do have to dispose those too. Every kind of resource heavy object is good to dispose of. Like I said, it keeps that footprint low and allows your game to run efficiently. So what else? Sorry, I'm kind of all over the place right now. There's just a lot to kind of set up. But I believe we got the basic cameras going. We got our world. So with that, we left the player uninitialized, so we can kind of jump into that. Player equals create player. So let's go down here. Public body, because the player is a body object. Create player. And body, p body, return p body. Okay. That's just so the player will have a reference to the body that we create. If you don't save any kind of reference, it's going to be kind of hard to do force impulses and applying forces to specific bodies, because then you'll have to go through, I believe it's like world.get bodies. Yeah, it's just a big list of all the bodies that are in the world, and that's kind of a mess to sort through, and it'll create some inefficiencies. So let's see, we're going to create and set up the physical properties of the body, and to do that you use a body def, which is a body definition. That essentially describes the physical properties that the body will have, whether it has friction values, the initial position, the type of body, whether it's dynamic or static. Static being it doesn't move, it's a solid, non-movable boulder object, or a dynamic body is one that can accept forces and move around and is affected by gravity. You can also set like fixed rotation, which we will do here for the player. So body def equals body def dot, or I'm sorry, new body def, just got ahead of myself there, def dot type. So this is where we'll choose the dynamic or non-dynamic type for it. So there's that. And let's set the position set to 0, 0, def dot fixed rotation, just so the body doesn't rotate, equals true. If it's false, it'll rotate upon hitting objects, or depending on what's deflecting off it, stuff like that. So we don't want any forces to interfere with the rotation of our object. So with the definition set up, we can go ahead and create body dot or equals world dot create body with our body definition. And what that does, it kind of initializes our body and puts it into the world using the physical properties we set up here with the definition. So that's just an entity. It doesn't really have a shape or form. It just is a little blip that has these physical properties. So let's give it some shape. Go to polygon shape. There's tons of shapes. There's circle shapes. I don't really know how many shapes there are. I typically use polygon shape anytime I want to create a box. So shape equals new polygon shape, and then shape dot, there's a set as box method, and we are going to want to just do kind of a basic 32 by 32 setup. But do note that Box2D likes, or when you give something a width and a height, it takes it from the center. So if you say 32 for the width and 32 for the height, it will essentially be 64 for the width and 64 for the height, because it'll take from the center, so it'll go 32 up and 32 down and then 32 left and 32 right. So we're going to want to just divide that by 2 for now. 32 divided by 2. And there's that. So now we have a 16 by 16 box, or a 32 by 32 box, sorry. And then with that, we can give the body the shape. Create fixture. And we give it the shape, and we'll also give it a density. Typically, just give it a density of 1, unless you want a heavier object, then give it more density, or make it more dense. And then after that, we can dispose the shape, because, yep, that does have a dispose method. As I said, keep it clean as much as you can. Things that you're done using, just get rid of. So with that, we created our player, gave it some physical properties, and threw it into our world. Then we gave it a shape. And we return that as a reference so we can do things with it later. So our player has been created and put in our world now. And let's see, so right now we still aren't going to get anything on our screen because we haven't allowed the debug renderer to display stuff yet. So let's get that going so we can actually show some progress, so we don't feel like we haven't done anything yet. And to do that, we're first going to have to make sure that the world is updating. Now, like I said, this is where all the logic happens. So we're going to need the world to, it's world.step, yeah, 1 divided by 60 frames. That's kind of its constant delta number. Velocity iterations, good practice just from what I've heard from everyone. They'll tell you 6 and 2. Just use 6 and 2. Those are essentially how many calculation steps happen. You can tweak those, though you're not really going to see a big difference. It just kind of changes how smooth the motions are. 6 and 2 is a very good happy medium to keep the calculations down while keeping the frame updates up. Then we'll go into, let me think, what should we jump on to next? So we have our player, we have our world, we have our camera kind of just doing something. It's just looking. And so I guess with that we can just apply our Box2D renderer, render our world, and you also give it camera.combined. And so I'm just going to try and run it, and you're going to notice something. It's not really going to show us anything. And I'll get to that in a second, and then we can start adjusting from there. So I'll let that run real quick. Okay, oh, we do see something. So there was our box down in that left corner there. It does start at 0, 0, so we kind of have things working right. I wonder if I can just get that box to hold still for the moment by having a zero gravity. Okay, let it run. Let's see what else. Yeah, okay. Yep, there's our box. So it is right there in the corner, 0, 0. That is exactly where we wanted to put it. So things are actually working out all right so far. However, we want to kind of center it, just so the player is kind of the point of interest. So let's add a little camera update with the delta. I guess we don't really need a delta, but so public void camera update float delta. And this is going to just kind of center the camera onto the player's position. So I'm going to do a vector 3 position, and I'm only doing it this way so we can kind of implement some motions later. Camera dot position. So position dot x equals player dot get position dot x. Position dot y equals player dot get position dot y. And then we can do camera dot position dot set position, camera dot update to make sure that its matrix is updated. And then we can go back to here, and yeah, it's still combined. Okay, so we'll run it one more time, and this is where we're going to notice the weird things that I tried to show last time. And if it'll run here in a second. There we go. Okay. So that still didn't do the weird thing I was trying to get you guys to see, but oh well, whatever. Let's close that. Oh, I know why. Okay, so the reason it isn't doing the expected screen output is because it is still using the scale. It's using a very large scale. So essentially we just created a 16 meter by 16 meter box. That is huge. And that is really calculation heavy for Box2D. So this is where we get into the pixels per meter scaling. This allows your objects to stay small while still maintaining what you want them to do. So what I like to do is I just kind of like to create a new package. I'll just call it utils. Then we'll add a file, a Java class, called constants. And no, so get rid of that. This will be a final class, and public static final float ppm. I like to use that just because it's a good short name for pixels per meter, because Box2D does operate with meters, and that's kind of how you need to scale it. So like I said, our object, we want it to be 32 by 32. This will allow us to bind 32 by 32 images to it. So it allows us to scale our world to smaller sizes to get better calculation speeds. And so where we're going to want to apply this is not here, but rate, I believe, where is it? Oh, there it is. Okay, so anytime you use a Box2D variable, like as in you're getting information from the world and not giving it to the world, you want to take it and divide it by the ppm. And I'll show you how you can just use ppm alone without saying constants.ppm. I like to just import static com.conneranderson.b2d.utils.constants.ppm. Man, that is long, but that is what we're going for. So when you include this static and you ask for a specific variable out of there, you can just use that variable as is, as if it's in the class you're in. Now, it's not good design to use it a lot, but if you have a lot of these, like this constants class, it's just kind of nice to keep it short named so you don't have these long constant stop ppm. Like if you're using it all over the place, it's nice to have ppm over that. It reduces the amount of typing you're going to make yourself do. But like I said, don't overuse it. Use it very sparsely. So after that, we have scaled the position to match our view, but we also need to scale the player, where did we create that? Down here. Okay, so divide by ppm, divide by ppm. So that'll turn these regular units into Box2D units, and that is what we're going for. Let me make sure I actually got the camera right. Oh, right, so those should be times. So yeah, like I said, if you're giving a Box2D object units, divide by ppm. If you're getting Box2D units, like up here, like you're getting a body's position, you want to multiply it by the pixels per meter. So you kind of go back to your scale. And then what else? So then up here also you need to make sure to scale your Box2D renderer camera by the ppm. And if everything worked out right, that should give us essentially the same thing we had, but with the proper scaling. And there we go. That is perfect. That is exactly what I was hoping for. So we got everything right and all together. So we can close that, and let's add a platform. I think it's about time to add a platform. So we'll just platform. Okay. Platform equals create platform. Public body create platform. And you can kind of genericize, make these like methods generic for creating shapes and stuff. You can have like a create box method and just give it a width and height parameter. That's good practice to do. So let's see, we want body p. You know what? I could probably just take all this, and I think I'll just do what I just said actually. So int width, int height. We'll change this to create box. Width, height, and that'll return it, return it, return it, return it, fixed rotation, and then we'll also have boolean is static, so we can modify this. So if is static, def.type equal body def.body type dot static body, else do that. So I actually want to, just for better readability. So there's that. Create box 232 false. We'll do 6432 true. Okay, so that was pretty easy. Didn't have to write a lot of code for that. So keep in mind that also threw that box into the world, so now we have our player and our platform, and we have references to them. If it is just a regular platform that's never going to change, you don't necessarily need a reference unless you plan on deleting it later or something, or modifying its values. And so we are going to go down here. Let me see. Oh, you know what else we should have? Int x and y, just so it has a x and y position. X divided by ppm, y divided by ppm. I believe that's what we want to do, just so you can scale these values down to the Box2D world. So we have a, let's say 0 and a 10. and then here we can have a 0 and 0, maybe like a 2, I don't really know, maybe an 8. Let's see what that gives us, just to make sure I got those position things right. So these tutorials are kind of just, I'm learning what I'm going to be doing for them, so you'll have to bear with me for the first few until I get an actual format. But looks like what we got so far is our box on top of a platform box, and that's what we were going for. So let's get some simple motions in. How about it? So let's see. We need to go to our update method. And what we're going to want to do is just kind of have an input update. Delta, I guess we don't really, oh well, good habit. Public void input update float delta. Okay, so we created that, and so we can do int, we'll do a horizontal force equals 0, and then if GDX dot input dot is key pressed, yeah, is key pressed, input dot keys dot left. Okay, and import that. If GDX dot input dot is key pressed, input dot keys dot right. Okay, so we got those. These are essentially, so these poll for any keys that were pressed each frame update, and that's kind of how you check, is this right here. This has like every single key your keyboard will have. As you see here, you can essentially assign it anything you want. So yeah, we'll just leave that as left. So horizontal force minus equals 1, horizontal force plus equals 1. And we can go down here, and we have our player object because we kept a reference to it, and we're going to set linear velocity. What that does is it essentially sets this speed to exactly what we put it at. So we're going to want to do horizontal force times, I don't know, let's say 5. So what this will kind of do is it will set the x force, like if an object is given 5 newtons positive, it'll move to the right. If it's negative, it'll go to the left by with a force of 5 newtons, or a velocity of 5 meters per second. Sorry. And so how we kind of adjust for that to make sure it's not always going 5 meters per second is we can use these and this variable here, which is reset to 0 every time. So if we're not pressing anything, it'll be 0 times 5. So that'll be 0. So it won't be moving. Otherwise, if we have one of these keys pressed, 1, just like let's say we press left, it'll be -1. So it'll be -1 times 5 is -5. So it'll move to the left as intended. And let's say we have both pressed, that'll equal 0 again. So if left and right are pressed, we don't want to move, so it'll kind of compensate for that by doing that very simple 1 minus 1 arithmetic. And then for the velocity, we're just going to get, or for the y velocity, we're just going to get player.getLinearVelocity.y. That's because we don't want to set the y to anything because it is going to be influenced by gravity, and we don't really want that. So let's run it one more time just to see how we're doing, make sure our input is being worked in there, and that our box can now move. Um, so there we go, compiled, and let's move around a bit. Oh, there we go. And so if I kind of go off the edge here, if you remember, we don't have any gravity yet. So let's put that back in. And what do you say we add a jump just for no reason, just so we can kind of see that as an example to watch that gravity put some effect on us. Oh, we want just press this time because we're doing something a little different. Keys dot up, and that's kind of the up arrow on your D-pad, as these are corresponding to your left and right on your little arrow pad. We will do player dot apply force to center. Now this is a little different. This one just kind of applies a certain amount of newtons to your object. Now what that means is it is going to push your object with a little kind of like it punches it almost, I'd say. I don't know. That might not be a good analogy. But we are going to do the new vector, or I guess we'll just keep it simple. 0, 300, and false. Ignore the false. I'm not going to go into that right now. But so what this is essentially going to do is wherever our object is standing, we are going to apply 0 newtons to the left and right, the horizontal plane of our object, but we're going to apply a positive 300 newtons. So that means it should kind of punch our object up into the sky for just a second. It'll go against the gravity, and then gravity will kind of revert that back to 0. Kind of simple mechanical physics right there. So let's check it out. And do remember we did apply the 9.8 gravity, so we should see some effect there. So here's our box, and if we press up, oh, there's our jump. That's a very small jump, but it's what we intended. So here we go. And if we fall off, you can kind of just keep tapping up, but if you hold up, it won't just shoot your guy into the sky. If you have key pressed instead of is key just pressed, it'll essentially, what's the word? It'll double up on the forces that you're applying to the center. So every frame while you're having that up key pressed will apply 300 newtons to your object positive. So it'll be 300, 600 minus the 9.8, then 900 minus the 18 points, or 19.6. It'll just kind of add up like that. So you just want is key just pressed for that one button accept. So yeah, there we go. That is going to be it for this tutorial. We got our basic box. We got a Box2D renderer showing us what's in our world. We have a little player object that's 32 by 32 in the camera's view, and we have a platform, a static body. As you can see, it kind of denotes that by being green as being inactive and static. And all dynamic bodies are pink. I believe that's pink or something around a little hue of red. So with that, we will continue later. I believe next tutorial I want to get through would probably be the tiled integration, or maybe vice versa, Box2D integration into utilizing tiled maps. So thank you for watching. If you want to see more of these videos, subscribe. If you think I screwed up on something, or am just talking too much, or need to get my material strengthened, let me know. As far as I can tell, this is a very simple project. We didn't really create any classes, so I hope it was easy to follow for the most part. I'm still learning myself how to do these videos. So with that, have a good day.